first speaker today is going to be, we're going to have two speakers, Dennis Camara from NIST and Mark Kustner of NCLSI, and Mark will be our first speaker today. Mark will speak on standardization, digital calibration, and measurement capabilities. And Mark holds a degree in electrical engineering and physics and consults with 31 years of metrology experience. He chairs the NCLSI metrology practices and MII automation committees. He writes the metrologists towards a measurement information infrastructure column and manages editing for the NCSLI Measure, the Journal of Measurement Science. NCSLI's Measurement Information Infrastructure initiative seeks to standardize automated data exchange for metrology. And I also invite you to check out Mark's most recent article in the issue of the NCLSI Metrologist. It's a very, very good article on the same topic that he is talking about today. So welcome, Mark, and please go ahead with your presentation.
Thank you, Jim. Hello, everyone. Thank you. You see my screen okay?
Yes. Okay.
Yes, Mark. We see it.
Great. So thanks for everyone for your attendance. As Jim said today, I want to talk about standardizing digital CMCs. Hopefully a topic that interests everyone. After a short introduction, we'll discuss digital transformation just a little bit and how taxonomy fits into that. We'll look at developing a taxon and CMC for airflow as an example of how we build these in the MII context, and look at some other further examples to get a more rounded view with a short conclusion. So with that said, here's a few acronyms and such you may or may not have seen just for reference. Primarily today, we'll discuss the MII and the taxonomy for CMCs and touch a little bit on the M layer. So just a quick blurb about NCSL for those of you unfamiliar. Initially established in 1960 as an American organization. It's now an international organization, has been for some time. As Jim mentioned, we published a couple of magazines, a journal, various standards and recommended practices. In 2015, NCSL convened the 141 committee to focus on this MII concept. And so we've been working on these things since then. You may find further information at this Wikidot site. So just a quick summary of digital transformation. So I think everyone's familiar with this, just so we're clear on the ideas. This slide shows a progression from the old days of manual operations through analog technology, digitization. This is our first of three terms that we want to disambiguate: digitalization and digital transformation. You can see where in metrology we've gone from typewritten certs to most folks issuing certificates in PDF form. We really haven't caught up with the rest of the industries that have fully transformed themselves. But we hope with initiatives like the MII, the DCC and such, that we'll get that digitalization in full swing and enable some of the innovations that will result from digital transformation. So although we are behind, we have started, and as everyone knows, with BIPM and OIMO and various other organizations having signed a joint statement to this regard, I think everyone's behind it now. The second point that I want to make with this slide is just that simple digitization doesn't suffice. So if we just digitize our existing processes, we won't really gain the full value that we want from digital transformation. So we want to go the whole way. So with that in mind, this slide shows the MII concept, Metrology Information Infrastructure. We envision these three documents: instrument specifications, certificates, and accreditation scopes, as carrying the majority of the information throughout the digital metrology economy. So MII is mostly focused on accreditation scopes, but the work that we've done easily translates to these other two documents as well. So keep that in mind, because I know the DCC is at the forefront of everybody's focus these days. So to make digitalization and digital transformation possible, the machines require metadata to process these documents. So this information flows back and forth through the international quality infrastructure, but at every step we have a human interpreting, generating, and processing these documents. So we want the machines to do that, and to enable that, we attach metadata to that data in these digital documents. For metrology, metadata primarily means descriptions of the measurands, and for that we've established these MII taxons. And so, for example, you see DC voltage taxons here below. So a specification for an instrument might tag a particular function of that instrument with source.voltage.dc. And then correspondingly, a lab would advertise the capability to calibrate that function by tagging in its accreditation statement the information with measure.voltage.dc. And then when you turn around and calibrate an item, those measurement results would be tagged with source.voltage.dc. And that would tie all this information together so that machines could process it automatically. You probably remember Blair Hall, I think, previously talked here about the M layer. So just a quick review on that. The M layer is based on the idea that to digitally transform our industry, we want to rethink things from the ground up. And in metrology, the ground is pretty much quantities and units. So the current systems we have for human use don't really suffice for machines to disambiguate quantities. So the idea with the M layer is that rather than writing quantity values as a numeric value in a unit, we would also attach what we call an aspect ID, such as an ID for voltage and an ID for pressure, so that digital processing for uncertainty propagation or any type of calculation would know how to handle those quantities without human intervention. And it would distinguish quantities. We call them aspects to generalize the term quantity kind, so it applies to all different scales, not just ratio scales. But for example, voltage isn't simply voltage. There's any number of different aspects and scales for these quantities. So we would be able to distinguish historical values in terms of 1990 conventional voltage versus SI9 versus SI8, et cetera, et cetera. So that M layer disambiguates the quantities for machines, but that doesn't cover measurands. So the idea with the taxonomy is to disambiguate the actual measurands that we want to communicate in these documents. So corresponding to these voltage and pressure examples, we might have any number of different measurands. For example, source.voltage.AC sine wave for for alternating current sine wave measurement, or this pressure example. And in instrument spec documents or calibration certificates, there might be additional qualifiers to distinguish different features of the instrument. But each one of these MI taxons would map uniquely to an M layer ID, and so that all the quantities under that particular data section would have the proper aspect identifier to identify the quantity values. So that's the basic idea. So in this section, we'll just look at an example of developing a taxon for airflow. It's a complicated enough example that it illustrates most of the cases that we'll get into as we develop these. And what we're doing here is establishing not only a taxon, but a template for all the data that goes into CNC. We're creating an abstraction from which laboratories may create their own CMCs for their own specific situations. So as starting assumptions, we just assume that we're going to calibrate mass and volume flow meters with either air or dry nitrogen. And we're going to assume that to date in the taxonomy, we have nothing established for airflow. So we'll go through this step by step. In each step, you'll see down here in red a basic rule that we use to govern how we form these taxons. In blue, we'll see the taxon as we develop it. And in between is something of a human readable version that you might see on an accreditation scope. So first of all, we're going to start with either source or measure in our taxon, depending on the capability, whether we're sourcing a value for a measuring instrument or vice versa. In this case, we said we're calibrating flow meters, so we're going to source airflow for that purpose. Next rule just says we separate our tokens by periods. Easy enough. And then from there on, we describe the quantity in more and more detail. So we're saying airflow. And this taxon that we build is going to be a unique identifier that we put in digital documents. So it's not necessarily, even though it's fairly human readable, it's not really intended for human readable documents. So we allow a set of aliases to correspond to that. So this might be in different languages or different terminology according to a given sector. So we simply just put airflow for now on the human readable version. Now our next rule says these tokens should follow the upper camel case convention, so we delete the spaces and capitalize the words. That doesn't change, though, the human readable version. Next, though, these tokens for the quantity name are not, the quantity kind are not arbitrary, so those need to be established in the MII taxon as unique values. So since we assumed it doesn't exist yet, we go to the MII registry, we find it out it doesn't exist. We find out the MLayer doesn't have an aspect ID for airflow. So we want to do some research to figure out what kind of terminology we want to use. So if we go out to the various sources like the KCDB, the ISO 80,000 document series, as well as all the various accreditation agencies, we quickly find for these Measurand that there's a whole variety of terminology and names, and it quickly becomes confusing to sort out the quantities and the terminology. But that's our job here. It's not a problem because our object is to determine a unique identifier for these. So we get busy with it. We go out and look at more sources, and it gets more confusing. There's terminology for related quantities like evaporation with different names, and for unrelated quantities that use some of the same terminology. So it becomes a task to sort that out, but that's what we're doing. So if we boil that down, we quickly find out that, well, maybe not quickly, but there's four basic quantities. There's mass flow, volume flow, plus ratios and coefficients. Mass flow covers leaks. There's fluids, so it's not just airflow, it's fluid flow. That could be a gas or a liquid with differing measurement processes. There's various types of fluids. You have inline and non-intrusive meters. So after looking at all that, we would propose adding 2 taxons to cover our particular needs in our laboratory. So mass flow rate and volume flow rate. And while doing so, we might come up with a hierarchy, a partial taxonomy to cover this particular measurement area. So we can source and measure these quantities. We have mass and volume flow for either gas or liquid, inline or non-intrusive meters. And you can kind of see how we qualify these taxons further and further. We also have ratios for labs that issue meter correction factors, and coefficients for those meters that say output a voltage in response to a flow rate. And I should point out that really the whole taxon matters as a whole. The machines don't really pay attention to the individual tokens except for the source and measure. So back to our steps of developing the taxon, we change from airflow to mass flow rate and concentrate on that particular taxon. And we also changed the human readable version because that's more descriptive and more specific, which is kind of a general principle that comes out of this as we clarify what goes into digital documents, because machines require that disambiguation. We also get better at writing it for human purposes. So then we just add further taxons to further qualify our Measurand. So we're going to calibrate mass flow rate of gases with ambient air. And in our CMC, we can add that information too. We'll do it either with ambient air or dry nitrogen. However, another rule says that we have this parameter capability. So calibrating with ambient air or dry nitrogen really amounts to the same process. So we don't want separate taxons for that. We'll handle that with parameters. So it's similar to, say, calibrating thermocouples. There's various types of thermocouples, but the type can just become a parameter under one taxon, because it's all a volt. If you're simulating a thermocouple, it's always a voltage versus a temperature. Whereas if you're simulating a platinum resistance thermometer, it's a resistance versus a temperature, so that would be a separate taxon. So we drop the ambient air from the taxon, and we have our taxon completed. To go along with that, though, we want a definition for human purposes, so that we can easily select a Measurand from a list, a taxon from a list for the Measurand of interest. And so if we go out and search definitions for flow, we find this in ISO 80,000. And we just elaborate on that for more clarity for someone trying to figure out which taxon to use for a given purpose. So now we have a taxon and a definition. You may have heard the American expression, lies, damn lies, and statistics. So that implies that statistics are the worst kind of lie, but they get a bad reputation simply because we abuse statistics and we don't specify the conditions under which they apply. It's the same thing with calibration. We want to define our Measurands very completely so that we don't lose the value of calibration. We have this concept of definitional uncertainty, and we want that uncertainty to be relatively small compared to the other uncertainty components so that we don't swamp them out. In worst case, our definition, our Measurand is so bad compared to how the instrument is used that it swamps out the accuracy specification and makes the calibration worthless. So to avoid that, we want to fully describe the Measurand state. So that involves the influence quantities, input quantities, any property values, or relevant operating conditions. So this becomes part of our CMC template. And if we go out and research the process of mass flow rate, we find any number of different influences that might either alter the uncertainty or give options that the customer might want to choose between. Now, all these don't necessarily apply to any given lab situation, so just depending on the uncertainty level, the traceability level, and the customer requirements, any given lab may drop any or all of these parameters from their particular CMC. But this is the abstract template that we want to develop to cover any situation. Now, some of these are required and some are optional. So to do any kind of a search on a capability or mass flow rate, we'd want to know the value of the flow or the range of interest. And we might want to know the values of some of these other parameters as a customer searching for a capability. But for our particular example here, I flagged all these others as optional parameters. But that also may change depending on the lab situation. So this is kind of a human readable version of the CMC template as we've completed it. So we have a taxon to uniquely identify it. We have a definition for human use. And then the CMC would encode all this information in an XML data format. So the required and optional parameters with ranges. And when that CMC is taken and filled out, it becomes a concrete CMC and an SOA. The ranges would be filled in with values, and we attach uncertainty in the whole works. But this is our template. And if we look at it in a human readable form, if you compare this to, say, airflow CMCs that you see out there in the wild, you'll notice that this has quite a bit more information than you would typically see. But here I've listed not only the range for our CMC with a simplified uncertainty, but also the fact that it's a source to definitely disambiguate that from a measurement. And we're showing the ranges or default values of all the relevant quantities. So if the customer may select either dry nitrogen or ambient air. If they don't specify, we'll default to ambient air, we'll default to 23 degrees C, 800 kilopascal static pressure, but we have capability over this range, et cetera, et cetera. So it's much more complete information for searching and using CMCs, communicating them between organizations. Now we've worked with NRC. We're starting to work with NRC to work on some of their service codes and KCDB entries. The first one we looked at was this microphone calibration capability. So it's essentially a pressure sensitivity, a ratio of voltage to pressure. And there's a couple different methods, primary and secondary. Secondary method uses a standard microphone, whereas the primary method doesn't require one. It's traceable to fundamental SI quantities. So this is some information from the KCDB entry for one of those relevant quantities, and the service code from their website. And you can see kind of a textual, human-based information here that we would encode digitally with some of this other information. And we come up with something like this as a taxon for that particular measurand. So we're measuring a coefficient and reporting a coefficient of voltage to pressure. And in particular, it's an AC voltage as an root mean square value. It's a differential pressure, also root mean square. And there's a few different options for doing this microphone measurement. So in this particular case, it's called a pressure field measurement. So we select measure because microphones source their values like a gauge block. So we want to measure capability to calibrate that source. Its coefficient and further descriptions. So you can kind of get an idea of how this works. And we also specify parameters such as nominal sensitivity of the microphone, the primary parameter, as well as the influence and input quantities, frequency, pressure range, etc. Now there's a number of other factors that go into any calibration, in this case like cavity dimensions, impedance, various other parameters. But those typically are not something that the customer selects a service from. They're just details, internal details to the process, so they don't become part of the CMC template. And the question comes up whether the primary and secondary calibration require different taxons. Probably not. It's the same quantity, just like if various labs up and down the traceability chain measure DC voltage, they'd identify it with the same taxon, source.voltage.dc. And so that probably applies to this as well, although the pressure field token on the end may or may not apply. These are all draft taxons, and so we expect to refine them given some expert participation. We've also done a starting taxonomy for some photometric, or rather radiometric quantities that NRC supports. And here's some of the parameters that would become involved with those: wavelength, various angles, sample size, polarization types. Within the MI group, we've worked on quite a few taxons. You see some of those here. These are all drafted and out there for people to look at and give us feedback on. Here's the rest of them. So it covers quite a range, but by no means not everything. So we're looking for a lot of collaboration and support to help develop these. So just to conclude quickly, digital transformations coming our way. Everyone here knows that. We think this MI initiative gives a way to digitize CMCs and also tag the data in digital calibration certificates. So keep that in mind. As you have your DCC projects, these taxons might become useful for identifying the data in those documents. We hope they'll produce a lot of benefits and make these documents interoperable. And so we'd certainly like to collaborate with you in developing these. We've set up a site with NRC's help on GitHub for managing this collaboration, taking submissions and improving new taxons into the taxonomy. And so you can find that site here. It's currently not public, but if you send an email to Ryan Light at NRC or myself, we can get you access and get you involved in that. Otherwise, our current information sits out on this website at CalLab Solutions, and there's an informal list here. CalLab Solutions has some open source software for developing this taxonomy and editing digital accreditation scopes. So you might want to look at that. And then there's, of course, there's more information at the Wikidot site. So thank you very much for your attention, and many thanks to the organizers and everyone who has supported this effort.
Okay, thank you, Mark. That was a really great presentation. I see we have at least one question in the chat, and so now we will have quite a few minutes for questions, so people can chat them in. So first question is says thanks, Mark, for sharing your knowledge. If you can clarify if this taxonomy description will be open and free available. Will it be required to subscribe or authenticate somehow to use it or to download it?
Thank you. Yes, thank you for the question. That's a great question. It is completely open. We intend it to be an open, fair source. So we're using the GitHub to facilitate that. The NCSLI committee will make decisions on the particulars of the taxonomy. However, anyone may join NCSL and become part of that decision process. Many of your organizations are already NCSLI members, but the taxonomy will be free and open, downloadable. You can actually get it now at the current GitHub site that's open. You can download not only the taxonomy itself, but also the software to edit these taxons and accreditation statements.
Just to sort of follow up on that question, Mark, is the intention at some point to turn this into a standard through, you know, through one of the standards organizations?
Yes, as we develop the taxonomy in parallel, we'll be developing the specification document. That's already drafted, so that's where some of the rules that you saw on the slides come from. But that's also a collaborative effort. Initially, it'd probably be a free and open NCSLI document, but we're certainly open to that becoming some other type of standard.
Is there other questions that are not chatted in? So just to sort of follow up on that again, Mark, what right now you have to sort of request permission to get on the GitHub to view it. So do you anticipate there will be yet an even more public mode of sharing and downloading the taxonomy in the future?
Yes, I think so. We just haven't opened it up yet. So the new GitHub site is I think about 3 weeks old. So we're still populating it with the information from our previous repositories. So yes, it'll certainly become much more open.
Seems like so how many folks are on the committee right now that are actively working on this?
good question. Our typical meeting, we have regular Monday meetings working on this taxonomy, by the way, and we're open to establishing further meetings at different times to match up with people in different time zones. But a typical meeting has 5, 6, 7 people involved, but the committee has quite a few more involved. Fluke Corporation is working with us also to set up, they've built a draft registry for the M layer, so we'll tie the taxonomy to that once that gets more established.
Have there been any adopters of the taxonomy at this point?
Only in the accreditation statement to this point. So we think NRC is looking at adopting it. We've presented this to the APMP group, the Asia Pacific Metrology Program, and we have some initial interest from NMIJ and MSL and the UAE NMI. So we're hoping to fire this up and get some momentum going.
Yeah, Javier has asked if we could repeat the name of the NCLSI committee. Maybe we can put that in the chat. Can you put that in the chat, Mark? Just the name of the committee so they can look it up. Yeah,
I'll do that as we go along.
Somebody else asked if we could get the presentation slides of today's talks. I believe that the presentations will be online at some point after the meeting. And so Ryan asks, from the NMI perspective, the initial effort would be to define taxons which correspond to the KCDB CMC. How can introduction of the MII taxonomy in the KCDB help with adoption or standardization?
Yeah, great question. So we've had some discussions also with BIPM, and part of the idea is to link these taxons to the individual KCDB entries via their internal IDs. So turns out through their API on their website, we can get those identifiers and make those links. But having taxons associated with each of the KCDB entries would certainly facilitate flowing this concept down through the international quality infrastructure from, everything traces to these KCDB entries. So the taxons would be very similar going down the measurement chain. And there's obviously some service codes that NMIs and other labs have that aren't directly linked to KCDB entries, but that would just require some modifications or expansion of the taxonomy. So the KCDB forms a really nice starting point for disseminating the taxonomy.
So Rodolfo has a comment and question. He says, a very good presentation. One question: what is the difference of this taxonomy effort and the BIPM Digital SI?
Yeah, good question. So the BIPM Digital SI primarily focuses on encoding quantities and units in digital data. So it's looking primarily at how do we represent a kilogram, how do we represent a meter, etc., in the digital data. The taxonomy expands upon that. So with the M layer, you have a little more disambiguation between units and scales, and encompasses more unit systems than just the SI. And then the taxonomy adds further disambiguation for different measurands within the same type of quantity.
Thank you, Mark. Are there other questions? So another question I had, Mark, is has there been a particular industry or area that's been more interested in this than others? I think you mentioned Fluke. That would sort of suggest electrical measurement and temperature, things like that. Are there a particular industry area that's most interested in this right now?
I think it's pretty generalized. I don't think it's specific to any one measurement area, but there's interest from software companies, not just Fluke, but other software companies. And of course, software is the key to making this whole transformation work. So, you know, there's a bit of a chicken and egg scenario there, but I think we'll get through that. But in terms of measurement areas, I think it's pretty generalized. The taxons we've developed cover, say, 80% of the types of measurements out there, but probably only 10% of the individual CMCs due to what's, you know, way out there in the tails. So a lot of work to do there.
So Ryan has another question. It says, with the recent CGPM joint resolution, there is a broader effort to develop the SI digital framework. The taxonomy would be an important part of the metadata. I guess that's more of a comment. I don't know if you have anything to expand on that.
Yeah, that's a good point. We're actually presenting the M layer to the CIPM expert group on the digital SI as one of the possibilities for encoding quantities and units.
Thank you.